What happened? క్లాస్ ఇంకా స్టార్ట్ అవ్వలేదు.
Good afternoon, ma'am. Is it audible, students?
Good afternoon.
Good afternoon, ma'am. Last class you attended,
ma'am.
Good afternoon, everyone.
Good afternoon,
Good
ma'am.
afternoon, ma'am.
What, ma'am? Good afternoon. Last class we have completed kinetic theory of gases and coefficient of viscosity, diffusion of gases. Yesterday, no?
Yes, ma'am.
Transport phenomena we completed yesterday. Okay, now we will start thermodynamics. My important topics. First we discuss, then we derive the derivations in that. So yesterday class, diffusion of gases, viscosity, coefficient of viscosity and conductivity completed. Now we started thermodynamics topics. Okay. Now we discuss about thermodynamics. What is thermodynamics?
Ma'am, you are telling second unit, ma'am.
Yes.
First unit completed, ma'am.
First unit maximal distribution is there, later that is only takes two classes minimum. That is difficulty to understand and to derive the derivation in the final exam. So that first we completed important topics. That's what we started second block.
Okay,
That we concentrate transport phenomena, maximal distribution takes derivation part, that is soul in the. So that we started second unit. That is thermodynamics. Okay. Thermodynamics. So now I will send you wait. Is it visible on the screen?
Yes, ma'am.
Okay, thermodynamics. Thermodynamics is a branch of heat. Thermodynamics is a branch of heat in which we study. Thermodynamics is a branch of heat in which we study heat in motion and the transformation of heat energy into mechanical work and vice versa. Mechanical work and vice versa. So thermodynamics is a branch of heat in which we study heat in motion. Heat in motion and the transformation of heat energy into mechanical work and vice versa. In thermodynamic motion, a finite quantity of matter or prescribed region in space upon which our attention is concentrated, is called thermodynamic system. Okay. So thermodynamic system. Here a finite is it visible on the screen?
Yes, ma'am.
Thermodynamics is a branch of heat in which we study heat in motion and the transformation of heat energy into mechanical work and vice versa. So here thermodynamics is a branch of heat. So thermodynamics is a branch of physics. It is a branch of heat in which we study heat in motion and transformation of heat energy. We study heat in motion. So in motion, how heat will be changes and the transformation of heat energy into mechanical work and transformation of heat energy into mechanical work and vice versa. Now thermodynamic system. A finite quantity of matter or prescribed region in space upon which our attention is concentrated is called thermodynamic system. Thermodynamic system, a gas contained which our attention is concentrated is called thermodynamic system. Example, a gas contained in a cylinder with a movable piston is the example for thermodynamic system. What is boundary? The system is surrounded by, is it audible? The system is surrounded by an envelope is called boundary. The system is surrounded by an envelope is called boundary. Boundary may be a real physical surface. Boundary may be a real physical surface or it may be an imaginary surface. Boundary may be a real physical surface or it may be an imaginary surface enclosed in some matter. Boundary may be a real physical surface or it may be an imaginary surface enclosed in some matter. That is called boundary. Surroundings. These topics are important to understand the concept of thermodynamic and open system, closed system, isolated system for different types of process. These are the basic things for thermodynamics. Next, the surroundings. The things which are outside the system and influence its behavior are known as surroundings. The things which are outside the system and influence its behavior are known as surroundings. The system and surroundings are quite arbitrary. Here system and surroundings are quite arbitrary means how to boundary that one layer, that is called boundary. The behavior of the system can be described, termed in the terms of macroscopic and microscopic properties. How to describe the system? Some microscopic and some microscopic. Macroscopic properties describes the gross characteristics of the system. These also explain average behavior of molecules of the system. These also explain the average behavior of molecules of a system. These are the classical approach of the system. These are measured directly by simple mathematical formula. What are the concepts here you're using, ma'am? Pressure, volume, temperature, etc. Pressure, volume, temperature. Microscopic properties describes the internal structure of the system. Microscopic properties describe the internal structure of the system. Microscopic properties describe the internal structure of the system. In this case, we studied about molecular level things. In this case, we studied about molecular level things. In this system, we can studied about the molecular level things, macroscopic and microscopic. These are statistical approach of the system. What are that? Velocity, momenta, energy, all these are microscopically we studied the system. In general, there are three types of systems. One is open system, one is closed system, one is isolated system. So generally systems are of three types. One is open system, one is closed system, one is isolated system. What is open system? A system in which both mass and energy, a system, vibruta vyavastha, samvruta vyavastha antam kadamma. Here a system in which both mass and energy transfer takes place between system and surroundings. Between system and surroundings is called as an open system. Between system and surroundings is called as an open system. Here open system, mass entering and mass leaving, and system and surroundings mass, both mass and energy is transfer. The type of system is called open system. That was shown in diagram. Is it clear? Systems are three types. First one, open system. What is mean by open system? A system in which both mass and energy transfer takes place, then it is said to be open system. So entering and leaving both are possible in open system. And this next closed system. In the closed system, what it is? A system in which only energy transfer takes place. A system in which only energy transfer takes place between system and surroundings is called closed system. In this, mass remains constant, might does not transfer. If the mass within the system is remains constant, if the mass within the system is remains constant, is called closed system. Or a system in which only energy transfer takes place between system and surroundings is called closed system. System and surroundings, energy transfer as work. Energy transfer as work, system to surroundings and surrounding to system. Next one, isolated system. What is isolated system? A system in which there is neither mass nor energy transfer across the boundary. A system in which there is neither mass nor energy transfer across the boundary is called as an isolated system. A system in which there is neither mass nor energy transfer across the boundary is called as an isolated system. Is it clear? Three types of system: open, closed, isolated. Open means both mass and energy transfer surrounding to system to surroundings. In closed system, entire mass is constant, that is called closed system. Or a system in which only energy transfer takes place between system and surroundings is called closed system. Isolated system, a system in which there is neither mass nor energy. A system in which there is neither mass nor energy transfer across the boundary is called as an isolated system. Okay, ma'am?
Yes, ma'am.
Okay, next, properties of a system. What is properties of the system? Thermodynamic system means every system has certain characteristics by its own physical condition, may be described such that characteristics are called properties of a system. Example, pressure, temperature, volume. Pressure, temperature, volume, etc. Properties of a system may be described in two types. One is intensive properties, one is extensive properties. What is in a system is having different types of properties. First one is intensive properties, second one is extensive. What is mean by intensive? The properties which are independent of the mass. The properties which are independent of the mass in the system are called intensive properties. Example, pressure, temperature, density, specific heat, etc. Pressure, temperature, density, specific heat is the intensive properties. And extensive properties means the properties which are depend on the mass. The properties which are depend on the mass in the system. The properties which are depend on the mass in the system are called extensive properties. Example, mass, volume, entropy, enthalpy. Extensive properties means the properties which are depend on the mass. The properties which are depend on the mass in the system are called extensive properties. Mass, volume, entropy, enthalpy is the examples for extensive properties. The properties which are independent of mass in the system is called intensive, which are depend on the mass in the system are called extensive properties. Pressure, temperature, density, specific heat are not depend. It is independent. Mass, volume, entropy is depend on other qualities, that is pressure, volume, temperature, etc. So that these are extensive properties. When all the properties of a system have definite values, every system is having definite values. The system said to exist. The system said to exist at a definite state. The system said to exist at a definite state. Properties are the coordinates to describe the state of the system. What are that? Change of state. First one is change of state. Second one is path of change of state. First one is change of state. Here what we are discussing, any operation.
Ma'am, your mic is on mute.
Ma'am, not listening your voice, ma'am.
Is it audible, ma'am?
Yes, ma'am.
Okay. Next, here what it is, my change of state. Then what it is, any operation in which one or more of the properties of a system, in which the properties which are depend on the mass in the system are called extensive properties. Over. Now, change of state. Any operation in which one or more of the properties of a system changes. Any operation in which one or more of the properties of a system changes is called a change of state. Next, path of change of state. The state passes through during the change of state is called path of change of state. The state passes through during the change of state is called path of change of state. The state passes through during the change of state is called path of change of state. Okay, ma. Change of state means any operation in which one or more of the properties of a system changes is called a change of state. the state passes through during the change of state is called path of change of state. Next, equation of state. Equation of state means an equation. Equation of state means, wait.
Ma'am, a small clarification.
Tell me.
These topics are not in our books, right?
Not in it?
Our book is showing Unit 2 as zeroth and first law of thermodynamics.
I will tell you. Starting only I said, no, ma, these are the necessary to understand that concept. This is not in syllabus. This is just understand the concept of thermodynamics. That's what only I am telling first.
Okay. I wasn't
Okay,
there.
these are the basic
starting. Sorry.
These are the basic things to understand the concept of thermodynamics, zeroth law of thermodynamics, thermal equilibrium, isothermal process, internal energy. That are your syllabus. Now I started. Okay.
Okay.
Okay, then next, equation of state is an equation related to the thermodynamical coordinates and expressing the complete behavior of the system in equilibrium is called equation of state. In thermodynamics, generally we are explaining the force of pressure, volume, temperature, that is constant. Next, process. When the path is completely specified and defined is called a process. When the path is completely specified and defined, when the path is completely specified and defined is called a process. Example, isothermal process, adiabatic process. Next one, indicator diagram. What is mean by indicator diagram means the graph between pressure and volume of the system undergoing operation. The graph between pressure and volume of a system undergoing operation is called indicator diagram. The graph between pressure and volume of a system undergoing operation is called indicator diagram. Here, consider a given mass of gas is enclosed. Consider a given mass of gas is enclosed in a cylinder fitted with a movable frictionless piston. Let A, P1V1 be the initial state of the gas and B, P2V2 be the final state of the gas as shown in figure. Okay, ma? Consider a given mass of gas is enclosed in a cylinder fitted with a movable frictionless piston. Let P1V1 is at point A, P2V2 is at point B, the final state of the diagram. The intermediate change of process are represented by different points AB like C and D. The different points on AB indicates the state of the gas as it changes its states A to state B. The area of the figure bounded by PV curve and volume axis given the work done by the gas. The work done by the system or on the system. The work done by the system or on the system depends not only the initial and final states. The work done by the system or on the system. The work done by the system or on the system depends not only the initial and final states but also on the path of the process. The work done by the system or on the system depends not only the initial and final states but also on the path of the process. That is called indicator diagram. Now our topic is Zeroth Law of Thermodynamics. From this onwards, your syllabus is introduced. This definition is important. Okay.
Okay.
Okay, then zeroth law of thermodynamics. What is zeroth law of thermodynamics means? If two bodies A and B are in thermal equilibrium with a third system C, then also the first two systems are in thermal equilibrium with each other, which is known as thermodynamics. Zeroth law of thermodynamics. Okay, ma. If two bodies A and B are in thermal equilibrium, A and C also in thermal equilibrium, then B and C also in thermal equilibrium, which is known as zeroth law of thermodynamics. The definition is somewhat different. Is there my screen? If two bodies A and B are thermal equilibrium with the third system C, then also the first two A and B also thermal equilibrium, which is known as zeroth law of thermodynamics. Okay. Here means A and B are, when it is said to be thermal equilibrium, both the bodies are at same temperature, then it is said to be thermal equilibrium. What is the example? Suppose we taken one hot cup, one cold cup of water. Then what it is, after some time, what happen? Heat cup transfers the heat to the cold cup, and cold cup absorbs the heat. After certain time, what happen? Both the bodies are at the same temperature. There is no transfer of heat from hot body to cold body. Okay, then it is said to be thermal equilibrium. Are you identified? Are you understood, ma?
Yes, ma'am.
When it is said to be thermal equilibrium means two bodies are thermally contact each other. Well, suppose we are taken hot and cold body. Hot body loses the temperature, cold body gains the temperature. After certain time, what happened? Both the bodies are at the same temperature. So that both the bodies are at the same temperature. Then it is said to be thermal equilibrium. So here zeroth law of thermodynamics, what it tells means two bodies we are considering A and B separately, that nearby that A is thermal equilibrium with the third system C, B also thermal equilibrium with the third system C, then automatically the first two bodies A and B are in thermal equilibrium, which is known as zeroth law of thermodynamics. Here zeroth law of thermodynamics leads the concept of temperature. Zeroth law of thermodynamics leads the concept of temperature. Next one, thermal equilibrium. Whenever there is no heat exchange between the bodies are said to be in thermal equilibrium. The temperature in all parts of the system is uniform and same that of the surroundings. Then the system is said to be in thermal equilibrium. Okay, ma? Clear? Thermal equilibrium, zeroth law of thermodynamics. Is there any doubt?
No.
The property which attains the same value, as that of other body when they are put in contact with each other, for a long time is called temperature of a body. The property which attains the same value, as that of other body when they are put in contact with each other, for a long time is called temperature of a body. Or temperature is the physical property that tells whether a body is in thermal equilibrium or not with another body. Okay, the property which attains the same value as that of the other body when they are put in contact with each other for a long time is called temperature of a body. Means temperature, it is a measure of hotness or coldness of the body is called temperature. When it is said to be temperature is more or less means it is a measure of hotness or coldness of the body only, no? Therefore, temperature is the physical property that tells whether a body is in thermal equilibrium or not with another body. That is called temperature. Next one, internal energy. The energy possessed by a system, due to its molecular constitution and position of these molecules. The energy possessed by a system due to its molecular constitution and the position of these molecules, is known as internal energy. It is denoted by U. The energy possessed by a system due to its molecular constitution and the position of these molecules is known as internal energy. It is denoted by U. The energy possessed by a system due to its molecular constitution and the position of these molecules is known as internal energy. It is denoted by U. Okay, ma. Internal energy means the molecules inside the gas is constitutional collisions. Then it gains some energy. The energy possessed by a system due to its molecular constitution, arrangement of molecules, we get the energy. That energy is denoted by the letter U. So initial and final internal energy is there, ma. The sum of initial and final internal energies is equal to internal energy. Internal energy is a state of function and is independent of path. Internal energy is a state of function and is independent of path. It depends only on initial and final state. It depends only on initial and final state of the system. Next one, thermodynamical coordinates. What are thermodynamical coordinates? Pressure, volume, temperature. Describing the state of the system. Parameters pressure P, volume V, and temperature T. Describing the system. Hence P, V, and T are called. Hence pressure, volume, and temperature are called thermodynamical coordinates or thermodynamical variables. Okay, the parameters pressure P, volume V, and temperature T describing the state of the system. Hence, P, V, and T are called thermodynamical coordinates or thermodynamical variables. Next one, isothermal process. Okay, ma. These thermodynamical coordinates express all the process, ma. From that only we are calculating work done in isothermal process and adiabatic process. Now we discuss about the concept of isothermal process. What is mean by isothermal process? When your thermodynamic system undergoes a physical change in such a way that its temperature remains constant. Okay, whatever changes occurred in a system, it remains constant temperature is known as isothermal process. Then the process is known as isothermal process, or the change is known as isothermal change, or the process in which the change in the pressure and volume of a gas taking place. The process in which the change in the pressure and volume of a gas taking place at constant temperature is called isothermal process. In this process, the quantity of heat which is developed or lost is given out or taken from the surrounding. Boyle's law holds good for isothermal process. Boyle's law holds good for isothermal process. In this process, the quantity of heat which is developed or lost is given out or taken out from the surroundings. Here, Boyle's law holds good for isothermal process, ma. Okay. Isothermal process means the changes occurred in a thermodynamic system at constant temperature is called isothermal process. Now we want to derive the work done in isothermal process. For that, we take this diagram. The diagram means at state A or position A, what are the values of coordinates? Pressure P1 and volume is V1. X-axis indicated diagram like here, X-axis we are considering volume and Y-axis we are considering pressure. Therefore, let 1 gram mole of ideal gas is expand isothermally as shown in figure. Here P1, V1 be the pressure and volume respectively at initial state A, and P2, V2 be the pressure and volume respectively at final state B. During isothermal expansion, both pressure and volume change takes place. During isothermal expansion, both pressure and volume change takes place at constant temperature. Let pressure and volume be the let pressure P and volume be the at any intermediate state C. Now we assume that pressure P remains constant. For a small increase in volume dV. C to D. The work done by the gas during the small expansion. The work done by the gas during this small expansion is PdV. Okay, my first, and immediately we can't find out the work done isothermal process from A to B. We can considering small element to CD. If you are considering small element work done is dW, whenever you are calculating dW, we are getting integration of dW, we are getting total work done. Okay. Is it clear, Nana? Hence dW is equal to PdV, which is equation number 1. The net work done by the gas during expansion. The net work done by the gas during expansion from volume V1 to V2 is W is equal to integral V1 to V2 dW. Therefore, integral V1 to V2 PdV. dW place, we are substituting PdV, which is equation number 2. Now, for an isothermal process, PV is equal to RT. Then P is equal to RT by V, which is equation number 3. Now, are you following, ma? Small part work done. Generally, work done is equal to force into displacement. In the place of force, we are taken as pressure into area. Pressure is equal to force by area, no? Force exerting on a particular area is called pressure. Pressure is equal to force by area. Force is equal to pressure into area. Then work done is equal to pressure into area into displacement. Again, area into displacement means one more length. A into L, nothing but volume. Therefore, dW is equal to change in work done means change in volume we are considering. dW is equal to PdV, which is equation number 1. Are you following?
Yes,
is there
ma'am.
any doubt?
No, ma'am.
dW is equal to PdV. Now we are considering work done by the gas during the expansion from volume V1 to V2. Then W is equal to integral V1 to V2 dW. Integral V1 to V2 in the place of dW we are considering PdV. Then isothermal process, what is Boyle's law holds good, no ma? PV is equal to constant. In the place of constant we are taken as RT. Otherwise the ideal gas equation PV is equal to nRT. N is equal to 1 mole of gas. Then N is equal to 1 means PV is equal to RT. N is equal to 1 means PV is equal to RT. Therefore, for an isothermal process, PV is equal to RT, P is equal to RT by V, which is equation number 3. Now substitute equation 3 in equation 2. Substitute equation 3 in equation 2. Then W is equal to integral V1 to V2 RT by V dV. Then W is equal to RT integral V1 to V2 1 by V dV. Now integral 1 by V dV means log E of V. Therefore, W is equal to RT into log base E V. Integral 1 by V means log E V, no ma? Are you following? So RT by V dV, RT constant. Substitute in the place of P, RT by V in equation 2. Then we have V1 to V2, RT by V dV. RT is constant. Integral V1 to V2, 1 by V dV. Integral 1 by V means log E V. Limits we are taken V1 to V2. The gas expanding from V1 to V2 no, at the initial state A to B. Now applying upper limit minus lower limit. Then W is equal to RT into log base E. Upper limit is V2 minus lower limit is V1. Log base E V2 minus log base E V1. It is in the form of log M minus N. Log M minus N means log M by N, no? Then the mathematical formula that log of base E M minus N means log M by N. Therefore, RT log E in the place of M V2, in the place of N V1. Therefore, W is equal to RT log base C V2 by V1, which is equation number 4. Now, base C should convert it into base 10. Base C in base 10 ga convert cheyalante, we are multiplying with 2.3026. RT log base C base 10 V2 by V1, which is equation number 5. Is it clear, Nana? Base C should convert it into base 10 means we should multiply with 2.3026. Then it converted into 10. RT log base 10 V2 by V1. Now in isothermal process, what it is? Boyle's law holds good. Boyle's law holds good means P1 V1 is equal to P2 V2. From that, V2 by V1 is equal to P1 by P2. V2 by V1 is equal to P1 by P2, which is equation number 6. Now substitute equation 6 in equation 4. Substitute equation 6 in equation 4. What is equation 6, ma? V2 by V1 is equal to P1 by P2. In the place of V2 by V1 in equation 5, we are substituting in equation 5, we are substituting 6. Then what it is, ma? W is equal to RT log E base C means log E P1 by P2. If you are multiplying with 2.30 means it is base 10. Then it becomes 2.3026 RT log base 10 P1 by P2. Only V2 by V1, you are changing P1 by P2, which is in terms of pressure. Why? Because means here Boyle's law holds good. Is it clear? Is there any doubt? These two process work done is useful in Carnot cycle. That is next class we will discuss. Now isothermal process completed. Now we will start adiabatic process. It is clear? Is there any doubt, ma? Response, students. Is it audible?
Yes, ma'am.
It is clear now? Is there any doubt?
No doubt, ma'am.
What, ma?
No doubt, ma'am.
Okay, very good. Now we will start the work done in adiabatic process. What is adiabatic process? What is work done in adiabatic process, ma? Just now we completed isothermal process and work done in isothermal process, no? What is isothermal process? The changes occurred in a thermodynamic system at constant temperature is called isothermal process. Then final work done formula is RT log E V2 by V1. Otherwise, in terms of base 10 means 2.3026 RT log 10 V2 by V1. Now adiabatic process. In this, when a thermodynamic system undergoes a change in such a way that its total heat remains constant. Heat remain before processes, temperature remains constant. Ma. In this system, heat remains constant. Then the process is known as adiabatic process, and the change is known as adiabatic change. And the change is known as adiabatic change. When a thermodynamic system undergoes a change in such a way that its total heat remains constant, then the process is known as adiabatic process. Okay. When a thermodynamic system undergoes a change in such a way that total heat remains constant, then the process is known as adiabatic process, and the change is known as adiabatic change. Now, the process in which the change in volume and pressure of a gas takes place is thermally isolated system is known as adiabatic process. The process in which the change in volume and pressure of a gas takes place in thermally isolated system. In thermally isolated system is known as adiabatic change, or the process in which the change in volume and pressure of a gas take place in thermally isolated system is known as adiabatic process. Thermally isolated system, the process will occur, the changes will occur, that system is called isolated system. That process is called adiabatic process. In adiabatic process, there will not be exchange of heat energy between the system and surroundings. It is a isolated system. That's what only. It does not transfer heat energy from system to surroundings. In an adiabatic process, PV power comma constant holds good. Okay, in a isothermal process, PV is equal to constant holds good before equation. Now here PV power gamma is equal to constant holds good. What is gamma here? Ratio of specific heats, which is Cp by Cv. So here gamma is equal to Cp by Cv. Now we want to find out the work done in adiabatic process. Is there any doubt? Adiabatic process. Now, let 1 gram of mole of an ideal gas expand adiabatically, shown in figure from state A to state B. Let P1 and V1 be the pressure and volume. P1 and V1 be the pressure and volume respectively at initial state A. And P2, V2 be the pressure and volume respectively at final state B. Now, let P and V be the pressure and volume at any intermediate state C. Okay, immediately we can't transfer our changes occur from A to B. It is not expanding our compression, no? So that we are considering small part of work done from C to D. Okay, and what it is, let P1 and V1 be the pressure and volume respectively at initial state A, and P2, V2 be pressure and volume respectively at final state B. Now, P and V be the pressure and volume at any intermediate state C. Now we are assuming that pressure P remains constant for small increase in volume dV from C to D. The work done by the gas during the small expansion is PdV. Before also we are considering that work done only, no? dW is equal to PdV, which is equation number 1. Now entire work done during expansion from volume V1 to V2, we want to calculate. For that, work done is equal to W is equal to integral V1 to V2. From where to where it expanding? V1 to V2 dW. dW is equal to PdV. Integral V1 to V2 PdV, which is equation number 2. But for an adiabatic process, PV power gamma is equal to constant. Then P is equal to K by V power gamma, which is equation number 3. But P is equal to K by V power gamma. In the place of P, now we are substituting K by V power gamma. Okay, ma. Now we are substituting in the place of P, K by V power gamma. Then what it is in equation 3, substitute in equation 2. Then W is equal to integral V1 to V2, K by V power gamma dV. K by V power gamma dV. Is it clear? W is equal to integral V1 to V2. In the place of P, now we are substituting K by V power gamma into dV. Is it clear, ma? Okay. Now W is equal to K integral V1 to V2 V power minus gamma dV. V power minus gamma dV. Then W is equal to what, ma? K into V power minus gamma plus 1 by minus gamma plus 1 integral limits V1 to V2. Okay. Are you following? Respond, students. W
Yes,
is equal
ma'am.
to, okay, W is equal to K into K by V power gamma. Then it becomes K taken constant, that is outside. Then integral V1 to V2 V power minus gamma dV, ma. K as usual constant. Now K integral V1 to V2 integral V power minus gamma means x power n dx means what you are taking, x power n plus 1 by n plus 1, no? Same way here also we can take V power minus gamma plus 1 by minus gamma plus 1 limits V1 to V2. Then W is equal to K by 1 minus gamma. Minus gamma plus 1 means 1 minus gamma, no? Then upper limit minus lower limit. Upper limit is V2 minus gamma plus 1 minus lower limit V1 whole power minus gamma plus 1. Now that K take inside. Then what it is, ma? W is equal to 1 by 1 minus gamma. That K is multiplying with both the terms. Okay. K multiplying with both the terms. Then it what happened, ma? K by 1 minus gamma into V2 power means take inside K means it becomes K V2 power minus gamma plus 1 minus K into V1 power minus gamma plus 1. Okay. Now in the place of K, we are substituting which lies holds good here. PV power gamma is equal to K. Then P1 V1 power gamma is equal to P2 V2 power gamma is equal to K. Now we are substituting that values in this equation in the place of K. Here first term V2 is there, then we can substitute P in the place of K. Instead of K, P2 V2 power gamma. Similarly, in the second term, in the place of K, we can take it as P1 V1 power gamma. Why? Because means in the second term V1 is there, in the first term V2 is there. So that here K instead of K, P2 V2 gamma. In second term instead of K, P1 V1 power gamma we are substituting. Okay. Then what it is, ma? W is equal to 1 by 1 minus gamma. Now bases equal means power should be added, no? Then P2 V2 power gamma minus gamma plus 1. Gamma minus gamma means cancel each other. V2 power gamma means V2 only. Therefore, 1 by 1 minus gamma P2 V2. Similarly, second term P1 V1 power what, ma? Gamma minus gamma plus 1. Bases equal means power should be added. Gamma minus gamma cancel each other. V1 power 1. Nothing but P1 V1. Therefore, W is equal to 1 by 1 minus gamma P2 V2 minus P1 V1. But ideal gas equation, what it is, ma? PV is equal to RT. For 1 mole of gas, RT, N mole of gas, nRT. So that we can take in what, ma? T1 V1 is equal to P2 V2. That is Boyle's law. Here ideal gas equation means P1 V1 is equal to RT1. Similarly, P2 V2 is equal to RT2. So instead of P2 V2, we are substituting RT2. Instead of P1 V1, we are substituting RT1. Then in both the terms again R is common. In both the terms again R is common. R is common. Then what it is, ma? R by 1 minus gamma into T2 minus T1, which is equation number 4. Okay, which is equation number 4. Now what, ma? R by 1 minus gamma. Minus is common means 1 minus gamma becomes gamma minus 1. Then W is equal to R by gamma minus 1 into T1 minus T2. Above one is compression, below one is expansion work done in adiabatic process. Okay, ma? Minus common means R by gamma minus 1, T1 minus T2. Above means R by 1 minus gamma, T2 minus T1. These two equations are work done in adiabatic process. These two are work done in adiabatic process. Okay. Okay, ma? Is it clear, students?
Yes, ma'am.
Work done in isothermal process over, work done in adiabatic process over. These two processes we are using in Carnot engine, ma. That we'll discuss next class. Now we will go for first law of thermodynamics. What is first law of thermodynamics? The amount of heat supplied to a system, the amount whatever you are supplying to the system is equal to the algebraic sum of the change in internal energy of the system. Algebraic sum of the change in internal energy of the system and the amount of external work done. The algebraic sum of the change in internal energy of the system and the amount of external work done by the system. Okay, that is called first law of thermodynamics. It is known as mathematical formula is delta Q is equal to delta U plus delta W. whatever amount, that delta Q is generally taken as a dQ, and delta U means du, that the PdV is nothing but dW. Therefore, dQ is equal to du plus, in general, dQ is the quantity of heat supplied to the system. A part of is used to increase its internal energy du, and the rest is used doing external work dW. Therefore, dQ is equal to du plus dW. dQ is equal to du plus dW is the first law of thermodynamics. Okay, the amount of heat supplied to a system is equal to the algebraic sum of the change in internal energy of the system and the amount of external work done by the system. It is known as first law of thermodynamics. Therefore, delta Q is equal to delta U plus delta W. The delta Q is equal, can be considered as dQ is equal to du plus dW. This equation is known as mathematical form of first law of thermodynamics. First law of thermodynamics is based on law of conservation of energy. First law of thermodynamics is based on law of conservation of energy. It works on the principle of law of conservation of energy. Here, amount of work done, then the certain amount of energy is produced. When a definite amount of work is done, when a definite amount of work is done, then certain amount of energy, then the certain amount of energy is produced, and vice versa. W is directly proportional to H. If you are removing directly proportional, we are taken as constant J. Therefore, W is equal to JH, where J is Joule's constant, where J is Joule's constant, which is mechanical form of equivalent term. So the mechanical equivalent of heat, that is 4.2 joule by calorie. J is Joule's constant, which is mechanical equivalent of heat, that equal to 4.2 joule by calorie. Okay, ma. This is the first law of thermodynamics. Is there any doubt in today's class? Work done, isothermal process, worked in an adiabatic process, first law of thermodynamics. And what are the basic things in thermodynamics? Introduction, thermal equilibrium, zeroth law of thermodynamics, adiabatic process, isothermal process, internal energy, temperature. These concepts we discussed. We already did, no? Is there any doubt?
No, ma'am.
Okay. Next, first law of thermodynamics in isothermal process, what? In adiabatic process, what means? In isothermal process means what, ma? Temperature is constant. Temperature is constant means there is no internal energy. Internal energy remains constant. Therefore, change in internal energy is equal to 0. At any point, temperature is constant means there is no change in internal energy. Therefore, change in internal energy du is equal to 0. All places internal energy same means du is equal to 0. Now, in the place of formula du is equal to 0 means first, what is first law of thermodynamics? dq is equal to du plus dw. du 0 means dq is equal to dw, which is application of first law of thermodynamics in isothermal process. Similarly, adiabatic process. What is adiabatic process, ma? Q is constant. Q constant means dq is equal to 0. At any place, amount of heat constant means dq is equal to change 0, no? Change in heat is equal to 0. Now, in first law of thermodynamics, instead of dq, we are substituting 0. Therefore, 0 is equal to dq is equal to du plus dw. In the place of dq, we are substituting 0 means 0 is equal to du plus dw. Then du is equal to minus dw, which is adiabatic process. Okay, ma'am?
Okay, ma'am.
Is there any doubt?
No, ma'am.
Okay, next class we'll continue. My time up now.